Good morning and greeting and welcome to all. This is B.S. Racheti. Now we are dealing with the topic mechanical systems of engineering, basic mechanical engineering, elements of mechanical engineering. This is lecture number 4 and slide number 4. We last time learned about this slide of nuclear power plant. Before going to deliver the next lecture or next slide, we'll have some recall of the memory of whatever we have learned in the last. So we have seen what is the nuclear power plant, what are the components of nuclear power plant, and what are working principle of the nuclear power plant, and merits and demerits of nuclear power plant. As you know, this is the main working principle of this nuclear power plant is it uses the fission process. As we know, the splitting of uranium atoms in a nuclear reactor. So by means of splitting of the atom of uranium into nuclei, what happens? A tremendous energy is being generated, and that energy is generated in the primary circuit, and that energy, or you can say heat, is carried out by this coolant, heavy water, that is example is it in the form of hot metal, and it flows through the heat exchanger, where it exchanges its heat to the water present in the tubes. That is, this heat exchanger we also call it as a boiler. So after giving its heat, it becomes slightly cool, and that cooled metal, you can say, pumped back to the nuclear reactor, where the endless process of fissioning process is taking place, and continuous heat is being generated and is being fed to this heavy coolant, and the circuit continues. So this is about the primary circuit we have seen. In the secondary circuit, so the water which converts into steam, superheated steam, is being taken to the turbine, where it converts this heat energy into mechanical energy by means of rotation, and this mechanical energy is further converted into electrical energy with the help of alternator, or it is also called a generator, so which is connected to the bus bar or grid, and that electricity we use in real life. So after the work of steam is over, exhaust steam comes to the condenser, where it gets condensed with the help of cooling water circuit, and then it is water then pumped back to the heat exchanger, or you can say boiler or steam generator. This is the secondary circuit. So this is in brief about the working principle, and the components, main components are nuclear reactor, heat exchangers, steam turbine, alternator. So we have seen nuclear reactor. So in this nuclear reactor, fuel rods, coolants, and moderators are also there to moderate. Control rods are also there. So these control rods controls the fission reaction. Moderators are used to moderate, means the reaction is very fast. To optimize it, the moderators are used. The coolant, which takes the heat from the fissioning process and give it to the secondary circuit, that is in the steam generator, heat exchanger, or boiler, to convert water into steam. So this is in brief about the working principle of nuclear power plant and the components. So we have seen it. Okay. Then merits and demerits we saw. Needs less space, fuel consumption is less, well suited for large power demands. Yes, absolutely. Less workmen required, absolutely. But capital cost is very high because of the cost of this fuel is very, very high. Radioactive wastes which are coming out of this fissioning process, if they are not properly disposed of, they have adverse effect on the environment. And as this area is totally radioactive, means the maintenance cost also goes on higher side. So these are the demerits of the nuclear power plant. Now today we'll start with the slide number 5 of lecture number 5 of this mechanical system engineering, and we'll see today this hydro power plant. So the word itself indicates hydro or tidal power plant means hydro, water. The energy which is obtained from the water, we can call it as a hydro power plant or tidal power plant. So we can directly start with the working principle. So as you are just to know the basic principle, advantage, disadvantages of this hydropower plant, and what do you mean by hydropower plant? So as the word indicates, the water is the energy which electricity which is obtained from water is called as a hydroelectric power plant. So I will explain this working principle with the help of figure and side by side the components, which is a one more part of the your syllabus. So what are the parts? First we'll see dam. So dam is a you can say a structure, concrete structure, which is meant for storing of or stopping of the water, flow of water. That is, and the area behind this dam is called as catchment area, and the water which is being utilized for power station is taken into the some another you can say storage, that is called as a reservoir, and from the reservoir there is a wall house. This, when this wall gets open, it goes to the turbine through penstocks. This penstock means nothing but a pipeline. So through the pipeline it goes to the turbine. So turbine again, blades, rotor is there, shaft is there. So when the water flows, that is the, so it is a dam constructed at a height in the mountain areas or at the higher places, so that there is a very high head is obtained if the dam is at a higher side. Okay, so what is that height? Can anybody tell? So that height is nothing but the potential energy of water. You can say potential energy of water is being when it is wall is open, it rush due to the gravity towards the turbine. What happens then? That is simple again. This potential energy of water, that is the head of water, gets converted into kinetic energy due to its speed or its motion. And this kinetic energy, when impinges on the turbine blades or buckets, the turbine rotates, that shaft rotates, that is kinetic energy gets converted into mechanical energy, and this further connected to generator, so that this mechanical energy is in the form of rotation, gets converted into electricity, and that electricity is sent to grid for use, our use. So this and after the work of this water is completed, at the exhaust here is a draft tube. That exhaust, it is called as a draft tube, and also this area of the outlet is called as a tail race, and the area at the inlet is called as the head race. So head race, reservoir, dam, wall house, surge tank, penstock, generator, turbine, and the tail race with a draft tube. So what happens? This water, when comes to the outlet, it is being sent through the canals to the farming or drinking purpose. This water is being utilized. So two functions: main is to generate electricity, and the another is to farming and drinking purpose. So now one more thing I may had to mention here, that is a surge tank. So the function of the surge tank, what happens sometimes or many times, if some situation arises in at the generator, means bus bar or grid side, so tripping of the turbine takes place. This may be the one reason, or some other reasons, that when the turbine trips, this wall gets closed and this water tries to rush backside due to the effect, water hammering effect, we can say. So that water, when try to rush backside, so there are chances of hammering and vibration. The pipe this penstock may get burst. So, or due to avoid that, this care of the hammering is taken by this tank, and water rush into the tank, and the air or any surge occurring in the pipeline is being taken care by this surge tank. Okay, so it avoids the bursting of the penstock or damage of the penstock. So this is about the components. So these are, one more is catchment area is the area behind the dam. Reservoir, it is the integral part of the power plant. So from the dam, from the catchment area, the water is taken to the another, you can say, area or a tank that is called as the reservoir, which means there is a minimum 20 continuous flow of water is ensured by the use of this reservoir. Dam, slipway, one more term is there. A structure is formed around the reservoir, so to remove this excess water. So if the excess water is coming from the dam, so it may damage the structure of the reservoir. In order to avoid that or overflow, some spillway is made or it is called as a slipway to avoid the damage to the dam as well as to the reservoir. Surge tank is the small tank is provided to reduce the pressure surges in the conduit. Conduit means pipeline. Penstock. Penstock are open or closed conduits that carry water to the turbines. They are generally made of RCC or steel. Water turbine, it works as an energy conversion device. Okay, and it is a machine through which the potential energy of water is converted into mechanical energy of the shaft. The main types of water turbine are impulse turbine, example Pelton wheel turbine, reaction turbine, Francis, examples are Francis and Kaplan turbines. So this Pelton, Francis and Kaplan are the names of the scientists who derived those turbines, who invented these turbines. So water turbine generators, so they are low RPM, means 75 to 300 revolutions per minute synchronous generators with main exciters usually mounted at the top of the shaft end above the turbine. So these are the components of the hydropower plant. Then merits and demerits of hydropower plant. So what are the merits? It is a more reliable power plant, low operating cost, because there is no need of fuel, extra fuel or oil or diesel or petrol, no coal. So cost of this automatically operating cost becomes very less, whereas also there are very less auxiliaries compared to the thermal power plant. Automatically operating cost becomes less. Low starting time, this is most important. So I have been to thermal power plant, and I also visited hydropower plant, and hydropower plant is system concern of our thermal power plant, and also we have seen the starting and stopping of these machines. So for thermal power plant, it takes minimum 8 hours to start the machine, whereas in case of hydel power plant, it takes only 5 minutes, hardly 5 to 10 minutes to start the machine. Just like we just switch on the button to when you get the fan on or tube on, like that. So simple in hydel power plant. So it requires, means it saves the time as compared to thermal power plant. High production rate capacity. If the ample water is there will be definitely continuous production of energy, electrical energy, and continuous high production rate capacity. The fuel cost is zero, pollution-free, renewable source of energy. Renewable, as already discussed, it can be and reused. So it is a renewable source of energy. It is not means exhausting. It is inexhaustible. Life of the power plant is around 100 years, you can say, up to 100 years. If there is no any damage to that main dam structure throughout the life, then automatically the life of the power plant is much, much more compared to other power plants. They are also used for flood control and irrigation. So if there is a heavy water in that area, particular area, so these dams make ensure to control the flood and also used for irrigation and drinking purpose. Disadvantage, capital cost is high. Naturally, with the construction of dam is not a joke. And it to be constructed in the hilly areas at the height. So automatically the initial cost and the capital cost is required for this hydro power plant is very high. Output depends upon availability of water. Commonly found in hilly areas, apparatus needs corrosion protection. And one more thing you can say, it is away from the load center, automatically the transmission losses are much more. That's all about the hydropower plant. And now again, quiz, or you can say MCQs. In hydropower plant, kinetic energy is converted into what? Electrical energy? No. Mechanical energy? Yes. Potential energy of water is converted into kinetic energy. Okay. Function of surge tank is to reduce pressure variation, reduce velocity of water, store water, all of all. So you can say reduce pressure variation is also there, or reduce pressure variations you can write like. Impulse turbines are Pelton wheel. Okay, only Pelton wheel. Hydropower plants take less time to start. Okay. Hydropower plant energy generation is very cheaper compared to other power plants. Hydropower plant produce more pollution, less pollution, no pollution, none of the above. It's no pollution. Hydropower plants are usually in flat surface, near sea, near forest, in hilly area. So answer is in hilly area. That's it for the hydropower plant. I hope I have tried my level best to explain you in brief and in simple language so that you can understand this concept of this hydroelectric power plant. Okay, with this, we come to the end of slide number 5, lecture number 5 of unit number 1. Okay, thank you very much.